powers of natural numbers, powers of numbers. Well, when we talk about powers of numbers, there are some rules that we should be familiar with that makes the work very easy. And here's the first one. What happens when you are multiplying two numbers that have indices and they share the same base? So here, let's start with the example at the bottom. We have the same number, 2 as the base, and we have 3 here as the exponent or index, and here again we have the 4. And the rule is very simple. When you have basically the same base, and that's very important, it only applies to when you have the same base. In order to get the answer, you simply add the exponents. So in this case, 3 plus 4 will give us 7. Pay close attention just to get a better explanation. We know that we could expand 2 to the power of 3 to mean 2 times 2 times 2. We could do that, isn't it? Here we have a multiplication sign. And we know that we could expand 2 to the power of 4 to be 2 times 2 times 2 times 2. Well, we know from what we've learned before, if we have 1, 2, 3, 4, 5, 6, 7 2's multiplying themselves, then we know the answer is definitely going to be 2 to the power of 7. But the quick way to have worked that out is that we know the base is not going to change. The base is still going to be 2. But here we had 3 of the 2's. And then we had 4 of the 2's. Well, we know that definitely altogether we're going to have 7 of the 2's. So it means that when you're multiplying an exponential number that has the same base, all you're going to do is add the exponents. So let's come up here and see it in algebraic form using letters here instead of numbers. Our base is A, and the A appears on both sides. That's the foundation. The base must be the same, and it means that we are just going to add the exponents, in this case n plus m. But don't worry about it. Mostly we are going to use numbers. So if you understand how it works with the numbers, then you will understand what the formula is trying to tell us. Well, let's prove that by having a little exercise here.